Hello everybody, we're going to be taking another look at 5.3, factoring trinomials where a is equal to 1. Okay, and remember a is the leading coefficient of a trinomial. Let me change that last one there. So we're saying where this value is equal to 1, right? And when that's equal to 1, usually you don't see anything there, right? So we'll have something that looks like that where b and c are going to be just real numbers and generally integers, and then you won't see anything in front of the x squared usually. Okay, and we'll see a couple of variations of that too. All right, so let's take a look at number 56 here from the book. So first of all, here we have more than one variable, right? We have two variables, and what we saw in the last video, we only had one variable, but it's the same idea. We still have a situation where a equals 1 here, so we want to set up our parentheses. This and by the way, this is not a perfect square trinomial, right? That's another way we know how to factor these, but 12 is not a perfect square, and so we can't do it that way. Okay, and another thing is we always want to check for a GCF first. Here there's no GCF, so they don't have any variables in common, nor is there a number bigger than 1 that they have in common. So we're going to do the type of factoring that we know that we learned in the last video. So since we have a y squared here, we're going to put a y here and a y here, because when you multiply those together, you're going to get y squared. And then here, so with that second variable, I have a t squared, so I'm just going to put a t here and a t here, okay? And then I'll figure out the numbers next. So with the numbers, we want to find numbers we can multiply to get 12 that we can subtract to get 1, right? There's an invisible 1 there. So what are numbers we can multiply to get 12 that we can subtract to get 1? So remember, if you're not sure, you can make yourself a list. What are the factors of 12? 1 and 12, 2 and 6, 3 and 4. And then once you get to a point where the next number is already on the other side of the other column there, then that means you're done with there are no factors, right? You could do 4, but then you'd be back to 3 and you're getting the same values. And so which of these has a difference of 1? This one here, right? So 3 and 4 are the numbers that we want to put in here. Okay. And remember, this is the sign of the bigger number, so that means this is going to be positive. And then this sign tells us if the signs are going to be the same or different. So negative means different, right? Difference, different. And so so since the signs are going to be different, that means this one has to be a negative, right? If this is a positive, this sign has to be different. Okay, so that's our answer. And remember, another thing you want to do is always check to see if can we factor more, right? That's not a difference of squares. That's not a difference of squares. So that's as far as we can go there. All right, so for number 60, same idea, right? No common factors bigger than 1, so I can't factor out a GCF there. This is not a perfect square, so it's not a perfect square trinomial. So now we're going to trinomial factoring. Okay, so I'm going to put an x here and an x here. Since I have an s squared there, no big deal, right? I'm just going to put that s in the back there. And then I'm looking for numbers I can multiply to get 24 that I can subtract to get 5. Okay, numbers we can multiply to get 24 that we can subtract to get 5. So if we need to, we can make a list of factors, right? So there's not a factor tree, it's a list of factor pairs, right? So we're starting with 1 and 24, 2 and 12. So I'm basically just starting at 1 and I'm just going down the list. Does 1 go in? Yep, 24 times. Does 2 go in? Yep, 12 times. Does 3 go in? 24 divided by 3 is 8, right? And once you find the answer, you can stop there, right? But I'm going to keep going just to show you the full list here. 4 goes in 6 times. Then when I get to 5, 5 doesn't go in, right? And so 24 divided by 5 is not a whole number. And so so now I'm at 6, and I already see 6 on this other side. So that means my list is done here, right? Okay, so which of those have a difference of 5? So I'm trying to subtract to get 5, right? So that's 3 and 8. So I'm going to put those inside the parentheses here, 3 and 8. Doesn't matter which order you put them in. But what does matter is their signs, right? This is the sign of the bigger number. So that's going to be negative. And then when the second sign is negative, that tells you your signs have to be different. So that means it's going to be a positive. If you forget those rules, just FOIL, right? This times this needs to equal negative 24s squared. So positive times a negative equals a negative, right? Okay. All right. And then the other thing is when we do our outer, inner, we're going to get, that's how we get the XS terms, right? X times negative 8s is going to be negative 8XS, and 3s times x is going to be positive 3SX, or x. Let's put the x first. So 3XS. And then when we combine these, that's how we get negative 5XS. Okay? So that's a way you can check if you're not sure, or if you forget the rules about the signs, you can FOIL it out and just make sure that you end up with this. Okay? All right. Let me clear that up a little bit.